So let's continue our discussion of program development, this time in the context of what is called Sentinel-Controlled repetition, which I'll describe in just a moment. First, let's take a look at our new requirements statement. And in this statement, we're saying that we would like to develop a class averaging program that can process an arbitrary number of grades each time the program executes. So of course, if I'm an instructor teaching a whole bunch of different classes, I'm probably going to have different numbers of students per class, and therefore it would be helpful to have a program that can input any number of grades, and once I tell the program there's no more grades to process, it could then go ahead and calculate the class average and display it for me. Now, when we don't know in advance how much data we're going to receive, we need some sort of indication that tells us when to stop processing values and that there is no more data to process. And that item is referred to as a sentinel value. Some people refer to it as a signal value, dummy value, or flag value, and basically it's an invalid piece of data that is used to indicate when the end of data entry has been reached. Now, this technique comes up a lot in different scenarios. It can be done certainly interactively by reading information from the user at the keyboard. It can also be done in the context of file processing, where the sentinel value becomes the end of file indicator, basically a notation that the operating system provides to the program to say you've reached the end of the file and there is no more data to process. So we'll demonstrate for the first time here a sentinel value, and because we're dealing with grades and grade values are 0 to 100, we will use an invalid grade, -1, as our sentinel value in this example. Now, this concept of sentinel-controlled repetition is also known as indefinite repetition because we don't know in advance how many times we're going to iterate. So in the preceding example, we knew we had precisely 10 grades, and therefore we will we would be able to specify in advance precisely the grades to process and the number of them. But here we're going to determine that on the fly. So now let's talk about the process of developing a pseudocode algorithm from scratch. And that process is something called top-down stepwise refinement. Basically, we begin with a single statement called the top that's going to represent the overall task to perform. In this case, determine the class average for the quiz, just a simple expression of what we want to get done. But as you see here, it does not say anything about how to implement the algorithm. It simply specifies what we need to do. So once we have a top representation of the problem, we can then begin a refinement process in which we break down or decompose the problem into multiple separate tasks. And for a lot of the basic problems that you'll solve, for example, in the early chapters of our book, you're going to find that the algorithms can be broken down basically into 3 phases. A phase in which you initialize some variables, so we'll create some variables to help us perform the calculations. A phase in which you process the data. In our case, we're going to input, sum, and count all the grades. And then a process in which you display your results, a termination phase, if you will, and that's where we're going to calculate and display the class average. Now, these 3 statements are basically top-level views of those 3 phases that I was just describing. And together, these 3 statements, which break down the original first statement, these are known as the first refinement. And the whole process of breaking down into more and more refined pseudocode is sometimes referred to as divide and conquer. Now, with these 3 statements, we can refine these further to try to really get our algorithm laid out. So let's go and talk about initialize variables. Now, in the preceding example, we had a variable called total where we stored the sum of all the grades. We also had a grade counter to keep track of how many grades there were, and then we had a list variable that had the exact list of grades that we were going to process. In this example, we don't know what the grades are yet, so we are going to break down initialize variables, at least for the moment, into initialize total to 0 so that we can keep track of the total of all the grades, and initialize grade counter to 0 so that as we process each grade we can add 1 to that grade counter to keep track of all the valid grades that we input. Now, it's possible after we start writing the code for the program that we could find the need for additional variables as we start to sketch out that code, in which case we might come back here and refine our pseudocode a little bit more, or we might simply use the pseudocode as a guide and then add the additional features we need into the code that we're writing. So we break down initialize variables into a list of the variables we need and what they should be initialized to. Next up, we take the second statement from the original first refinement, input, sum, and count the quiz grades, and let's turn that into an algorithm for doing just that. So of course we know how to input values from the user. So what we say here is input the first grade, possibly the Sentinel. So, you know, an instructor who is working with this program might execute it thinking that they're about to go calculate the class average and then decide, you know what, I don't want to do this right now. I'm just going to enter the Sentinel and terminate the program. So that's why we put possibly the Sentinel in parentheses here. Now, once we've read in that first grade, we are going to do a loop in which we figure out whether that grade is the Sentinel value or not, and if it's not the Sentinel, then we're going to take that as a valid grade and add it to the total. We're going to add 1 to our grade counter because now we have a valid grade to process, and then in Sentinel-Controlled iteration or repetition, the last thing you do in the body of the loop is get the next value, the next grade in this case. Again, that's possibly the Sentinel, so that as we hit the bottom of the loop's suite, we can come back to the top of the loop, check that value to see if it's the Sentinel. If it is, the loop can terminate immediately, and if it's not, then we have another grade to add to the total, and we can add 1 to the counter and get the next grade again, and once again, that may be the Sentinel value. So notice the difference here between using a for loop for sequence-controlled iteration versus using a while loop for Sentinel-controlled iteration. Also notice that for input, we do 1 input before we ever get to the loop so that we can then check if that might be the Sentinel value, and we do 1 input as the last statement in the body as well. So we'll see that implemented in code in the next video. So that was the second of the statements from the first refinement. We still have 1 additional statement from the first refinement, which was calculate and display the class average. So after the loop that we were just discussing on the preceding slide, we can break down this top level statement to an if-else statement that says if the counter is not equal to 0, that means if we have some grades, then we'll calculate the average by dividing the total by the grade counter, and we'll display the average. But we also want to be careful because the very first thing the user enters could be the Sentinel, which would mean we have 0 grades. And as you saw previously in Chapter 2, you are not allowed to divide by 0. That causes an exception at execution time. So if the counter is 0, we are simply going to display that no grades were entered to make our program a little bit more robust. So here is the complete pseudocode algorithm for Sentinel-controlled repetition. Just summarizing once again, we have 3 bullets here that represent the 3 basic phases of a typical program: the initialization phase, the processing phase, and the termination phase. In the initialization phase, we specify our variables and what they need to be initialized to. In the processing phase, we say how to deal, in this case, with the grades being input by the instructor or the user. And in the termination phase, we calculate and display our final results.